This is the X-rays on sample surface. Here we see red color shows the outer surface and green color shows the inner surface. This is the simple combinations of electrons which are placed here, but when X-rays are incident on it, they start collision. The reason behind this is that when X-rays are incident, so we also know that electrons are electromagnetic waves and highly energetic. When electron get that energy from X-rays, they start collision. When X-rays are incident on sample surface, so the electrons start collision. So if we see the X-rays on the surface, the X-rays will penetrate to the core electron of the atom in the sample. We have already seen this topic that X-rays will penetrate to the core of electron of the atoms in the sample. The second is that some electrons are going to be released without any problem, giving the kinetic energy characteristic of their elements. We also know that when X-rays are incident on the sample, electrons gain energy and increase its energy, the electron move from outermost shell. We have already seen this detail in detail in the diagram section. Third number, others electron will come from inner layer and collide with the others upper layer. We know that in inner layer, when electron absorb energy, they move to the outermost layer. In last conclusion, these electrons will be lower in lower energy. They will contribute to the noise signal of spectrum. So we see here the noise signal of the spectrum and how this is formed. See in further diagram. Here you can see clearly when the electron will collide and when the electron will not collide. But when X-rays are incident on a sample surface, the noise signal comes from the electron that collide with. So here you can see three different layers. When these electrons absorb energy from X-rays, they start collision. But when X-rays are not given to them, they have no collision, minimum collision. We consider it, there is no collision. So the collision causes a decrease in energy of the electron and it no longer will contribute to the characteristic of energy of the element when X-ray is incident and when X-rays are not incident. If we go into the energy level, we can see that at the absolute 0 Kelvin, the electron fell from the lowest energy state up. When the electron occupy to this level, the neutral solid is in its ground state. Here you can see the lowest energy state, which is named as ground state, and work function, which is known as phi, which is the work function, and this is the vacuum level, and this is the Fermi level. We have already studied in detail about this lower energy and vacuum level, Fermi level, and work function in this lecture. During XPS characterization technique, there is a question, why does XPS need UHV, means ultra high vacuum? This is very important factor during XPS characterization. So here we will know why we need UHV, ultra high vacuum. XPS is a surface sensitive technique. We already seen in detail in this lecture. Contaminants will produce an XPS signal and lead to incorrect analysis of surface of a composition. This means that when contaminants are present, our result will be not clear. If we want to be a clear result, we need to remove contaminants. We will set the pressure of a vacuum system to remove contaminants. So to remove the contamination, the sample surface is bombarded with the argon ion at 3K electron volt. Heat and oxygen can be used to remove hydrocarbons. So the XPS technique could cause damage to the surface, but it is negligible. And we also know that XPS technique is very useful because it does not damage the surface. If the damage occurs, this will be very small.